Unit 4 dove into our rational expression. So here you're going to have variables in your denominator of your equation. And so we'll talk through these and how to solve them. When we did it in class, we did it a couple different ways. I will primarily focus on what was the shorter method, because especially as you go into upper level math classes, doing the shorter way is going to pay off so much. If you need help doing it the longer way, if that's the way you would like me to help you with, feel free to reach out and I can help you however you may need. So what we talked about here is you want to first identify your LCD. Finding that LCD will not only help you with solving the equation, but also your domain. And so I would find that first. In this case, it's the least common denominator between a, 1, and 3a, which would be 3a. In terms of my domain, before we start the whole equation, your domain is everything except for what would make your denominator 0. Well, your denominator, you can just use this LCD and set that equal to 0. And so what we know is a cannot equal 0. So my domain needs to say everything but 0. And the way that we do that, it's going to be negative infinity to 0 and 0 to infinity. It's going to look like your rational expression domains did when we were solving them. So what I expect is anything but 0 that I get should be fine. And if I get 0, I need to get rid of it. For actually solving this, what we said was to go ahead and multiply the whole equation by 3a. And when we did it in class, we said, hey, that's really going to just distribute, so I would write it next to each fraction. What's going to happen is like these a's cross off, and it's just 3 times 2, or 6. The 1 has nothing to cross off, so it's going to be minus 3a. And then the 3a's cross off, and it equals 1. And then this is what we're going to solve. I'm going to minus the 6, divide by negative 3, and a is 5/3. In terms of checking, you just need to make sure that 5/3 isn't your excluded value. It's not, so we're done. For the LCD here, it's going to be x squared, because that was your most number of x's. We got to be able to cancel all of them out. What that means for my domain again, if I do x squared equals 0, I just get that x cannot be 0. Yes, it's mul2, but we didn't really care about that here in terms of our excluded values. It might make your graph look different, but it certainly will not change that it just can't be 0. Then I'm going to write x squared next to all of my terms. X squared divided by x in this first one means that I'm going to have an x times that 4x plus 3, so it'll be 4x squared plus 3x for that first fraction. Second fraction, the x squareds just cancel, so plus x minus 1 equal, here again, 1x cancels, and so it's just 1 times x, or x. I am looking at solving a quadratic equation here, so I need to get everything over here and equal to 0. If I minus x and combine my like terms, you're going to end up with just 4x squared plus 3x minus 1 equals 0. Then we're going to have to factor this. Multiplying to negative 4 and adding to 3 is going to be 4 and negative 1. Do take a second to factor that, but you should get x plus 1 and 4x minus 1 when you're done. To actually solve this, you set them equal to 0, so x is negative 1 or positive 1/4. Again, we're really just verifying that my answers are not my excluded values, so those both work. For one that looks like this, it is going to be beneficial for us to factor any denominator that we can factor to more easily find our LCD. If you factor this one, you should get p plus 5 and p minus 1. So I'm going to just cross that out because I don't need that right now then. What that tells me for my LCD, I need both the p plus 5 and the p minus 1, but this one already has a p minus 1, so I don't need an extra factor. In terms of my domain, before we go ahead and solve, I know from solving that p can't be negative 5 or positive 1, again just from setting these equal to 0 and solving. For writing my domain, this is good practice for those graphs. These are the really ugly ones that hypothetically had 2 asymptotes. It would be everything from negative infinity to negative 5, and then from negative 5 to 1, and from 1 to infinity. Again, when I did the overview video, I drew it on a number line for you to help out, if that helps. You know it can't be -5, you know it can't be 1, but it can be everything to the left. So that's, oopsies, that looks like an 8. Negative infinity to -5. It's going to be everything in the middle, which is the -5 to 1, and everything on the right, so 1 to infinity. So then we actually get to solve. I'm going to write p plus 5 times p minus 1 next to all of them. As you get better at this, you absolutely don't have to actually write it each time, as long as you're doing it correctly, so just be careful. On the first one, it all cancels, so I just have 2. On the second one, nothing cancels, so it's going to be the p plus 5 times p minus 1, technically multiplied by 1, but we don't need it. On the third one, p minus 1 cancels, and so I have equals p plus 2 times p plus 5. I'm going to have to multiply this all the way out, so 2, this becomes p squared plus 4p minus 5 equals p squared plus 7p plus 10. And if I try to combine some like terms, what I notice right away is these p squareds just cancel. So this isn't going to be a quadratic equation, it's going to be a linear equation that I have to solve now. Getting my p's on one side, I would have 3p equals 13, and so p is 13 over 3. Again, always verify if your answer is in your domain. It is, because it's not -5 or 1, and that's my correct answer. Last but not least, again for my LCD, right now I can see that these p squareds plus 5p match. I am going to factor them just to make it a little bit easier to see what my LCD is about to be, or what my excluded values are about to be. This tells me, for your domain, p cannot be 0, and p cannot be -5. So again, if the number line helps you, it can be everything negative infinity to -5. It can be everything from -5 to 0. And it can be everything from 0 to infinity. So I expect any answers in those regions. When you multiply this whole thing by p times p plus 5, you end up on the left side getting the p squared plus 5p because nothing cancels. But then the other two completely cancel, and so I'm going to have p plus 4 plus 1. It is a quadratic that's not going to cancel, so I need to set it equal to 0. And then go ahead and factor. When you factor all the way through, this is what you should get. Actually taking it a step further and solving, I get -5 and 1. Again, I need to compare my answers to the domain, and it specifically tells me -5 can't work, so I can cross that out. But 1 is in my domain. It's between 0 and infinity. So my only answer for this problem is p equals 1.